નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study about the zeros of a polynomial. This is the topic of standard 9, chapter number 2, polynomials. In previous class, we have studied about the introduction about the polynomials. Based on the degree of polynomial, we classify the polynomials in three parts. One is linear polynomial, second one is quadratic polynomial, and third one is cubic polynomial. So, to find the zeros of a polynomial, we will study here about the linear polynomials and quadratic polynomials. To find the zero of cubic polynomial, that portion we will study later. So, first of all, we will study about the linear polynomials. Okay, so till now, we know that what is the expression? Some particular type of expression in which if the variable is only one, then it is called a polynomial. Suppose x minus 2. So, we will see here that there is only one variable x and its power is 1. It is an whole number. So we can say that this is an polynomial and we denoted this as p of x. Now, as there is a variable x, we have write down it as p of x is equals to x minus 2. Now, in previous class, we also have seen that we have taken example of a square. And we know that as we change the value of the x, the value of the perimeter is also changed. So in this case also, as we change the value of x, the value of this polynomial is also get changed. So let's suppose we find the value of this polynomial p of x at x is equals to 1. X is equals to 1 means we have to put down 1 instead of x. So what will happen if we put in 1 instead of x? We will get p of 1 is equals to, now here we have to put x is equals to 1, minus 2 remains as it is. So the total value we get 1 minus 2 is equals to minus 1. So p of 1 is equals to minus 1. So value of the polynomial at x is equals to 1 is minus 1. Similarly, now we find the value of this polynomial at x is equals to 0. So we represent it as p of 0. Now instead of x, we have to put 0. So p of 0 is equals to 0 minus 2 and the answer is equals to minus 2. So you can see that as we change the value of x, we get the different values of this x minus 2 of this given polynomial. Now let us take x as a 2. So we find the value of p of x at x is equals to 2. So what will happen? P of 2 is equals to 2 minus 2. So 2 minus 2 is 0. So now as we know, we change the value of x, we get the different values of x. But for some particular values of x, we get the total value of the polynomial is equals to 0. In this case, if we put x is equals to 2, then this given polynomial becomes 0. And that is why this value of x is called the zero of a given polynomial. Right? So this 2 is the zero of this polynomial. Right? 2 is 0 of p of x is equals to x minus 2. So you may wonder that how to find this 0. Do we have to check every time by putting the different values? No. We have a method. So to do that, to find the 0 of the polynomial, we have to take p of x is equals to 0. That means in this side we have to put 0. So what will happen if we put p of x is equals to 0? this will becomes 0 and p of x is x minus 2. So what we do? P of x is equals to 0. We have to take. So what is the value of p of x? Is x minus 2. We have to compare it with 0. So x minus 2 is equals to 0. Now take this 2 to the right hand side. We will get the x is equals to 2. Right? So this value, whatever we get here, is becomes the 0 of this given polynomial. Right? That we have studied here. We have seen earlier. So in this short form, in this short way, we can find out the 0 of the linear polynomial. Okay? Once again, one more question arises in your mind is that how many zeros does a polynomial have? So there is a condition that number of zeros are less than or equal to the degree of a polynomial. See, the degree of this polynomial is 1. That is why we get the maximum number of the 0 is equals to 1. Right? We cannot get the number of 0 more than 1. Maximum number of zeros we get is equals to 1. For this case, that 0 is 2. Okay? So in this way, we can find out the 0 of the linear polynomial. Okay? Okay. So second type is of quadratic polynomial. One of the example of quadratic polynomial is p of x is equals to x square minus x minus 2. Here the degree of this polynomial is 2. That is why it is in the category of quadratic polynomial. So again, as we have seen in linear polynomial, we will find the value of this polynomial at different numbers. Suppose value of p of x at x is equals to 1. So what is the value of p of x at x is equals to 1? We have to put 1 instead of x. So we will get p of 1 is equals to, instead of x put 1, so 1 square minus 1 minus 2. 1 square is 1. 1 minus 1 cancel out each other. Minus 2 remains only. Okay. Now put minus 1. So we will now find the value of this polynomial at x is equals to minus 1. So instead of x, we have to put minus 1. So what we will get? Minus 1 square minus, instead of x minus 1, that is why minus is outside. Also instead of x, we have to put minus 1. So in the bracket minus 1, minus 2 as it is. The square of minus 1 is plus 1. This minus minus becomes plus 1 and this minus 2 is as it is. So this 1 plus 1 plus 2 minus 2 is equals to 0. So as I have said earlier that is we put for the value of the x, if the polynomials become 0, then that value of x is called the 0 of the polynomial. So here we can say that minus 1 is 0 of the given polynomial p of x is equals to x square minus x minus 2. So do we get the another values of the x for such that the value of polynomial becomes 0? Let us check. Now take the 0 instead of x. Then what will happen? The value of p of x at x is equals to 0 is p of 0 is equals to 0 square. Instead of x, we have to put 0. That is why 0 square minus 0 minus 2. This becomes 0. This will becomes as it is minus 2. So the answer of p of 0 is equals to minus 2. Not become 0. Let us take p of is equals to 2. So instead of x, now we have to put 2. So p of 2 is equals to 2 square minus 2 minus 2. Now 2 square is 4. This minus 2 is minus 4. So 4 minus 4 is 0. Okay. So now the polynomial's value becomes 0 where at x is equals to 2. So again we can say that 2 is 0 of the p of x is equals to x square minus x minus 2. So here we get the two values of x so that this given polynomials becomes 0. So here we get number of zeros is equals to 2. One is minus 1. Second one is 2. Again, to find the 0, we do not have to process this kind. We can find out the 0 of the polynomial by taking p of x is equals to 0. So by taking p of x is equals to 0, instead of a p of x, we have to put x square minus x minus 2 is equals to 0. Now we have to factorize these three terms. And you have studied already that how to factorize this. Okay, so to factorize this, we have to use the splitting the middle term method. So here, middle term coefficient is 1, here is 2. We have to factorize 2 such that its factors subtraction becomes 1. So what we have to do is 2 ones are 2, because 2 ones are 2 and 2 minus 1 is equals to 1. So we can write down here is x square minus 2x plus x minus 2. So we split this middle term minus x as minus 2x plus x. You can see that the simplification of minus 2x plus x becomes minus x. The first term x square and minus 2 we have put down as it is equals to 0. So now we have 4 terms. Take the common from the pair of 2 terms. So from first 2 term we get the x as a common. So by taking x as a common, what will remain here is x minus as it is. This x is common here, so only 2 is remain. From these 2 terms, nothing is common. So 1 we can take as a common. Plus 1. So in the bracket x minus 2 remains as it is equals to 0. Now from these 2 terms, we can again take x minus 2 as a common. So by taking x minus 2 as a common, what will remain? X plus 1, that we have to put in the another bracket. So x minus 2 in first bracket, x plus 1 in another bracket is equals to 0. Okay, so these 2 terms are in multiplication and their multiplication is equals to 0. This means out of these 2 terms, 1 must be 0, right? So we don't know that this portion is 0 or this portion is 0. So we will compare one by one both the term with 0 and find the value of x. So by comparing x minus 2 with 0, we will get x minus 2 is equals to 0. And by taking this 2 to the right hand side, we will get x is equals to 2. Now we will compare this x plus 1 with 0. Then what will happen? X plus 1 is equals to 0. Taking this 1 to the right hand side, what will happen? X is equals to minus 1. So we compare one factor with 0, then we compare another factor with 0 and get the value of x. And you can notice that this value of x 2 and this value of x minus 1 are, we have already seen that are the 0 of the given polynomial. So in this way, by factorizing the quadratic polynomial and comparing the factors with 0, we get the value of x, and that value of x becomes the 0 of the quadratic polynomial. So in this way we can find out the 0 for the quadratic polynomial. So now the third type is of cubic polynomial that we do not study in this class. First of all, we will understand how to factorize that cubic polynomial, then we will process the same way. Okay. Now one question is also there for the constant polynomial. We know now that what are the constant polynomial. So as there is no variable, there is no x. So what will be the 0 for the constant polynomial? Okay, as there is no variable, we can put any value, then we do not get the constant polynomial as a 0. So the number of 0 for the constant polynomial is 0. We cannot find any 0 for the constant polynomial. Second thing is 0 polynomial. 0 polynomial, what we are used to say 0 polynomial? 0 we said as a 0 polynomial. So there is also no variable, but it is the value of 0 polynomial is already 0. So every real number is 0 for the 0 polynomial. Okay. One more thing I have to say here is that for the quadratic polynomial, how many numbers we can get as a 0? We can get maximum 2 zeros for this quadratic polynomial. We cannot get more zeros more than 2. We cannot get 3 0 for this polynomial. Maximum number of 0 we get is equals to 2. That means we get 1 0 also. Both the zeros becomes equal. At that time we get only one number. Here we will get two different numbers. Okay. So this is all about to find the zero of a polynomial. Okay. Thank you. Thank you for joining us.